Well, good evening, everyone. This is Matthew, the observatory manager at the South Carolina State Museum, and welcome to our telescope live stream for tonight. So, unfortunately, it's a cloudy night tonight. Our plan was to show you some live views of Saturn from our telescope. Unfortunately, the weather had other ideas, and it's kind of cloudy and cold and icky outside right now. But never fear, we have some amazing video that we took of Saturn back in September, and that's what we're sharing tonight. So even though it's a cloudy night, you can get a really great view of Saturn from our telescope from some prior footage. So one thing that we'd like for you to feel very free to do is to place or put any questions or comments or feedback you might have in the YouTube or Facebook comments. Those will pop up right in front of me, and we will get those questions answered. Um, so please feel free to jump in and ask questions while enjoying our beautiful view here of Saturn. So I'm just going to hang out here and see if any of you all have questions. So I have a question for you all. Do you see how Saturn is moving? Is that actually the planet itself dancing around? Or is that something else? Maybe something a little closer to home? What do you think? So once again, if you've just joined us, we have this really beautiful video of Saturn that we've taken from our telescope here at the South Carolina State Museum. We unfortunately have a completely cloudy night tonight. We were going to show you a live shot of Saturn from our telescope tonight. But the weather had other ideas, so instead I have this video that we took earlier this fall that will give you a view of Saturn as well. So we're going to share that. And feel free, once again, to ask any questions that you might have in the Facebook or YouTube comments. And those questions should show up right in front of me here, and we'll get them answered. So we have Wes asking, will you zoom it onto Saturn? We may be able to do that in the software. This is actually very similar to how Saturn would look in our telescope. Um, it doesn't really look that big. And we're used to seeing really big pictures of Saturn, and that's actually from bigger telescopes, maybe bigger telescopes here on Earth or the Hubble Space Telescope, or in some cases, even spacecraft images of Saturn. So in a small telescope, Saturn actually does not look that large. But I'm going to go see if I've got a way of maybe zooming it in just a bit, and we'll see if I can do that here. Because, especially if you are watching on a phone, Saturn can look kind of small. So let's see, do I have an option to zoom here? Well, that just made it worse. I don't appear to have a really great zoom option here. So, again, this is kind of realistic as to what Saturn would look like in a small telescope. So, one question I posed earlier, don't know if we've had any responses yet, so feel free to jump in and respond to this one. You might notice how the video of Saturn makes the planet look like it's kind of jumping around or moving around a little bit. Do you think that motion is on the planet itself, or is that motion something closer to home, maybe like here on Earth? Or what do you think is causing that motion? Oh, your telescope is wiggling in the wind. I love it. So it's actually not the telescope wiggling in the wind that's causing that, but it is air currents in our atmosphere. The air currents in our atmosphere actually distort the light from really anything that comes in, like a star or a planet. This why you see the stars twinkle when you go outside and see the stars at night. It's actually air turbulence in our atmosphere kind of distorting and messing up the image. So the telescope itself isn't wiggling, but basically the air above the telescope is wiggling. And that's what makes the image appear to wiggle. Now, there actually are ways in which the telescope could wiggle and make our images look like they're shaking around. If you've ever been to the museum, and I know many of you have, you probably have walked under that giant tripod structure down at the front entrance. Basically, you walk in the front entrance and then you walk under this giant tripod that looks like industrial art. That is actually the support structure for the telescope. So the telescope's actually behind me here in our view, and it sits on that black pier, and the black pier sits on some concrete, which then sits on that tripod. And then those three tripod legs actually extend down to the ground of the floor of the museum, and they come into contact with some concrete pads, which extend all the way down into bedrock, so like 30 feet in the ground. This whole structure actually does not touch the museum building. And that's so as we walk around the museum or the observatory, or maybe cars go by on the street, or a gust of wind comes up, the telescope doesn't shake if the building shakes. So next time you're at the museum and you're wondering about that giant tripod that you walk under when you come in to go to the front desk to purchase your tickets, um, that's actually what it's part of. It's the support structure for the observatory. But of course, that's not going to stop us from seeing motion that's produced by the atmosphere above the telescope. So once again, feel free to pop any questions that you might have about our view of Saturn or space or the solar system or telescopes, anything astronomy related right there in those comments, and I'll see them and be able to answer your questions. What color is Saturn? Great question. So, right here in this picture, Saturn looks almost a little bit greenish, and that's because of the camera that we're using. But Saturn is sort of a pale whitish color, sort of maybe whitish to maybe a little bit sort of yellowish. And it also has these bands across it. These are actually cloud bands across Saturn. And Jupiter has something very similar, although the cloud bands on Jupiter tend to be quite a bit more distinct than the ones on Saturn. Joshua asks, how far away can you see? So that's a wonderful question. Right now, with our telescope, we're showing you something that we've taken within our solar system. Our telescope, though, can actually see things that are much, much further away. We can see things like nebulae and star clusters and such in our own galaxy. But our telescope can even see other galaxies beyond the Milky Way. It has a little bit of trouble doing that because we're here in the middle of a city, and those galaxies tend to be faint because they're so far away. But still, some of the brighter galaxies, like the Andromeda galaxy and such, we can see here from our observatory here in the middle of the city. So, yeah, we can see far, far, far beyond our solar system, even with our relatively modest telescope here in downtown Columbia. And Wes says, I know all of the gas planets. That's fantastic. So, of course, we have Jupiter and Saturn, the gas giants, and then there are Uranus and Neptune, which they're called ice giants. They're actually, the composition of Uranus and Neptune is kind of different from Jupiter and Saturn. And that's actually the subject of a whole nother program right there. It's the distinction between gas giants and ice giants. So once again, if you just tuned in, we're showing some beautiful video that we took earlier this fall of Saturn. We wanted to show you Saturn actually live in the telescope tonight, but the weather had other ideas. It's cloudy outside and kind of windy and cold, so it's not the nicest the night for astronomy. So never fear, we have this beautiful video of Saturn that we've taken in our telescope recently that we can share with you. So we can do some cloudy night astronomy tonight. Cloudy night astronomy is really kind of fun. So, and Wes says Andromeda Galaxy will collapse with the Milky Way in a very long time. That's absolutely right. So, in several billion years, the Milky Way and the Andromeda galaxies will actually collide with each other. Becky asks, how many miles should I travel to get to Saturn? Let me just look this up real quick here. I'm usually bad at remembering numbers, but Saturn is pretty darn far away. I just want to make sure I'm remembering it right here. So Saturn is almost a billion miles away. How about that? So when we look at this, we're looking at a planet that's about a billion miles away from us. And remember, I said that the telescope can see things that are much, much further away even than that. When we talk about the distances to galaxies, we're not talking about like billions of miles. We can be talking about millions or even billions of light years. A light year is the distance a light travels in 1 year, which is about 6 trillion miles. So the numbers that we work with in astronomy are truly huge. So another question for you all. Have you seen any of the planets that are visible in the evening sky right now? Just curious. Oh, thank you, Becky. Thank you. Have you ever seen a black hole with the telescope? So, with this telescope, we really can't see black holes directly. And one thing about black holes is that they don't give off their own light. But large telescopes can. You might have seen that first ever picture of a black hole that was released a few years ago. That was a black hole in a galaxy about 50 million light years away, and it was a network of radio telescopes all around the world that took that picture. So while our telescope, it's kind of a little bit too small to see the effects of a black hole. And that's mainly what you see is more the effects of around a black hole. Like maybe some stars are whirling around the black hole really, really fast. Um, so our galaxies, excuse me, I'm getting all off on a tangent there. So our telescope can't see those effects that you might see around a black hole, but larger telescopes can. Let's see. Thanks for all your distance info there, Michael. So, how many of you have seen Jupiter and Saturn in the night sky before? Feel free to pop in the comments if you have, without a telescope. You've seen Jupiter and Saturn in the night sky just with your eyes. So if you haven't seen Jupiter and Saturn, they're actually in the night sky right now. Of course, this is not a really great night to go be looking for things in the night sky. That's right, Michael. Neptune was the only planet to really be discovered, or the first planet to be discovered with math. That's kind of a neat fact about Neptune. So Jupiter and Saturn are in the night sky right now. They're roughly up in the south, actually more like in the southwest. Um, Jupiter is brighter than Saturn. So Jupiter will actually really catch your attention if you're looking off to the south. Saturn is over to the right of Jupiter, and it's quite a bit dimmer. And I'm going to make sure I just told you that right, because we've had some cloudy weather lately, and I just want to make sure I'm not really telling you something wrong. Yep, Jupiter and Saturn are right next to each other. Saturn is actually down and to the right of Jupiter. The other planet we have in the sky right now is Venus rather. So Venus is that really really dazzlingly bright star-looking thing that you'll see off to the west right after the sun sets. So as it's getting dark, look off to the west. You'll see a really dazzling bright thing. It's even brighter than Jupiter. Then that's actually the planet Venus. And of course, just as a reminder, we do hit the time change overnight. So we're going off daylight saving time onto standard time tonight. And that means that starting tomorrow, our sunsets will be a full hour earlier. And that means that it's going to really give us some great time for some early evening stargazing. So that's one of the neat things about this time of year is we're getting into a time of year when it's really easy to go out early in the evening and see uh, see stars and planets and all that cool stuff. By about 7, but tomorrow, by about 7 o'clock or so, it will be completely dark, and you can go see cool stuff in the sky. Yeah, Michael here is talking about Mercury. Mercury is actually one of my favorite planets to spot because it's always close to the horizon. It's not very far away from the sun, of course. It's the closest planet to the sun, so it always stays pretty close to the sun in our sky. And that means, from our perspective here on Earth, Mercury is always going to be fairly close to the horizon. Um, so one of the best places here in our area, here in the Columbia area, to see Mercury, if it's in the evening sky, is the Lake Murray Dam. So get out there on that path, that walkway there on the Lake Murray Dam if Mercury's out, and you hopefully will be able to catch a glimpse of it fairly close to the western horizon if it's actually up. Right now, I don't believe it is. Um, that's something every few times a year we do get those views of Mercury. Yep, that is right, Wes. Venus is the hottest planet in the solar system. It's actually hotter than Mercury, even though Mercury's closer to the sun, and that's because Venus has such a thick atmosphere. It has a super thick atmosphere to capture all of that heat there, and so Venus has what's called a runaway greenhouse effect. So, of course, right now you're probably hearing about it in the news. There's the COP26 climate summit going on in Glasgow, Scotland, and we're talking about ways to really address this climate emergency problem we have here on the Earth. So, Venus is kind of um, it's a sort of, uh, how do I put it? It's a really extreme version of the type of climate change we're seeing on the Earth. Much, much more extreme than anything we would ever see on the Earth. But yeah, that whole subject of climate change, Venus actually does come up as one of the other planets in our solar system that's kind of interesting to look at from that standpoint. So, if you've just tuned in, we're looking at some video footage of Saturn that we took with our telescope here at the South Carolina State Museum Observatory earlier this fall. Uh, we were hoping to show you Saturn live tonight, but the weather had other ideas. You'll go outside, you'll see that, at least in our area here in the Columbia area, it's really cloudy tonight. And it's cloudy and kind of windy and cold. So, definitely it's an icky night for telescopes and a good night for nice, cozy indoor cloudy night astronomy. So, on this cloudy night, I've got some really great video footage for you to enjoy of Saturn that we've taken in the pretty recent past. Now, if you have questions, feel free to pop those questions or comments or feedback in the Facebook or YouTube comments, and we will get those questions answered for you. So, I'm actually seeing your questions and comments as they come in. So feel free to pop those in and we'll have some nice interaction here. We've already had some really fun back and forth with some cool questions and comments earlier this evening. Thanks to people like Michael and Wes and Becky. So feel free to pop those questions or comments in the Facebook or YouTube comments. So I'm going to change the subject a bit. I'm going to keep our views of Saturn up. But I just am curious, how many of you all have seen some of the coverage in the news over, the past week or so about some of the solar flares and what we call geomagnetic storms that we've had? There have been some really spectacular northern lights displays over the past week or so. So how many of you have seen some things about that in the news? Pop that in the comments. If you've maybe seen a news article about solar flare or solar storm or northern lights, is Saturn always tilted on its side? So actually, that weird tilt that you're seeing is not the planet itself. It's just how the view is oriented in the telescope. Yeah, that's right. People saw the auroras as far south as Raleigh. Yeah, it was a pretty intense storm we had this past week. So Becky says yes on the weather. Yeah. Have any of you ever seen the aurora? Yeah, Michael, it's on my bucket list too, for sure. So the thing about the sun flaring up is the sun is really not doing anything like scary, weird, unusual. The sun actually goes through these cycles. So every 11 years or so, uh, the sun goes through a cycle where the number of sunspots goes up and then it goes down. So a few years ago, we were at the bottom of the sunspot cycle, and we would actually go like in like 2018, 2019, we would actually go months at times without seeing a single sunspot. But now the sun is entering the more active phase of this cycle. So over the next few years, we're going to see more and more sunspots and potential for more and larger solar storms and northern lights and all of that. So, 2024, 2025 is when the sunspot cycle peaks. Um, so, yeah, sun's getting more active. So Michael's talking about something here called the Carrington Event. This was a giant solar storm that happened back in 1859, and it caused the aurora to be seen all the way actually towards the equator. And this type of event is actually one of the things that it could happen. Back in 2012, there was a very similar solar storm to the Carrington event. The difference was in 1859, that huge blast when the sun went nuts was actually aimed towards us. And in 2012, the blast was aimed away from us. And so we didn't get it. But definitely, really big solar storms can affect our power grid, as Tracy's saying here. In fact, there's a pretty famous example in 1989 where there was a big solar storm that knocked out the entire power grid of the province of Quebec in Canada. Um, so an event like the Carrington event wouldn't like destroy life on Earth or destroy the Earth or cause a mass extinction or anything crazy like that. But what it would do is wreak absolute havoc with our power grid and our electronic systems. Um, so it is actually, it's one of the big reasons we study and keep a very close eye on the sun, is because the sun is really active and we're living with a star in our backyard, which is great, gives us heat and light, and all the things we need for life, but it also means that we're living with this pretty dynamic sphere of gas right in our backyard, not very far away from us. So once again, if you just joined us, we had a little tangent there about the sun. and the fact that we've had some solar activity the past several days, some solar, what's called a geomagnetic storm, and that caused some auroras fairly far south. But we do have here a view of Saturn. Unfortunately, this is not a live view from our telescope. We wanted to show you a live view tonight, but the weather had other ideas. And here in Colombia, at least, it's cloudy and kind of cold and windy. So it's not a great night for using a telescope, but it's a really great night for some cozy indoor cloudy night astronomy. So I thank you all for joining me for some nice cloudy night astronomy from the comfort of your home. And this is some video footage that we took of Saturn back earlier in the falls, back in late September. Um, Tracy asks, wasn't Jupiter hit with an asteroid or comet recently? I want to say it was. Let me just do a little news search here. Um, and that's actually that event actually is something that is not terribly uncommon. So let's see. Did Jupiter? Let's see. Is there some news about that? So yeah, so I'm seeing some news headlines that back in September something smacked into Jupiter. Um, so the thing about Jupiter is it's the largest planet. And that means Jupiter's gravity is stronger than the gravity of the other planets. And what this means is that Jupiter is by far the most likely planet to have something hit it because its gravity just pulls things like asteroids and such in, and then they can, and then it makes it really easy for Jupiter to get hit. So this is a really good thing because Jupiter actually will take a lot of that sort of space debris that might otherwise come and smack into us here on the Earth, and it actually smacks into Jupiter. So Jupiter actually kind of acts as a shield that keeps things here in the inner solar system a little calmer. That's right, Jupiter's a giant vacuum that protects the inner planets from space junk. Yep, that's absolutely true. What is the oldest planet? Asks Becky. So, really, all of the planets formed at roughly the same time. So, the sun formed about 5 billion years ago in this cloud of gas and dust called a nebula. And after the sun formed, there was this leftovers from that, and it was these leftovers formed this sort of disk of gas and dust and all of that um, was in orbit around the sun, and the planets coalesced out of that. And what this means is that the planets are actually all roughly, approximately, give or take a little bit, the same age. There isn't like one planet that's vastly older than another. So is Venus usually the first star visible at night? It is if Venus happens to be in the evening sky. So, like right now, Venus is in the evening sky. So, as it's getting dark, it's probably going to be the first thing that you see at night. Of course, if Venus is not in the evening sky, then that's not so much the case. But when Venus is in the evening sky, it is typically the first thing we'd see, other than the moon as it's getting dark. And then if it's in the morning sky, then it's one of the last things to fade from view as the sun gets ready to rise. And actually, for this reason, Venus is sometimes called the evening star or the morning star. And one thing I should emphasize is that Venus is not a star. Although it looks very much like a star when we look at it in the sky, it is actually indeed a planet. other bright thing that we'll start to see right now, it's not rising until way, way late in the evening. But especially as we start getting later into the winter, we'll start seeing a very bright star called Sirius um, in our evening sky. Sirius is the brightest star in the night sky, and the winter time is definitely the time of the year when we see Sirius. Isn't there an eclipse happening next month? Let's see here. There is a lunar eclipse coming up, and let me remind myself of when that is. Looking here, it is. So it's actually November 18th and 19th, but it's not really well arranged for us here in Colombia. Let me see if I can find some information on that eclipse for Colombia for you here. So we are going to use my handy dandy timeanddate.com website. Got Colombia here. Alrighty. So basically, for this eclipse that's coming up in a few weeks, the maximum eclipse is basically at 4 a.m. on November 19th. And it never goes total. It's just a partial lunar eclipse. We actually do have a total lunar eclipse visible from Colombia in May. So May 2022, we've got a total lunar eclipse coming up. Anita here, when are the next meteor showers? So we do have the Leonids coming up this month, and then they're the Geminids next month, and both tend to be pretty strong meteor showers. So yeah, we do have some meteor showers coming up. There's usually some type of meteor shower every month or so, but the Perseids in August, and then the Leonids in November, and the Geminids in December tend to be the biggest ones and the ones where you're most likely to see meteors. Now, it is also possible, especially if you're out under a dark sky away from a city, just to see random meteors. Even if there's no meteor shower going on, there's typically on any given night, there will be a few like random meteors that just go through. And again, you need to be under a dark sky to see that. But it's not uncommon for there to be like from a dark location, 1 to 2 meteors per hour. So one of the things you might see is the view of Saturn flickers out and then comes back. That's just the fact that the video is playing on a loop. Isn't the ISS usually brighter than Venus? I think that it varies depending on the paths that you're seeing and how everything's arranged and what the various angles are. Yes, the ISS can be quite bright. I don't know if it can be brighter than Venus, but it can certainly be super, super bright. Does the sun have a binary twin? So the sun is a single star. It's not a double or multiple star system. But that actually makes the sun very much the exception. It turns out that really a substantial proportion of the stars that we have out there in our galaxy and probably the universe are actually double or multiple stars. Um, so Yeah, our sun's a little weird for not being a double, for not having a twin or having another star in the system. Now, when we have a double or triple star or multiple star system, it's sometimes the two stars are really similar in brightness and in size and mass, and they are sort of like twins, but then sometimes they can be really, really different. Like you might have this really big, bright star, and then the other star in the system is much, much smaller and cooler. So it's common to have radically different types of stars in these double and multiple systems. Kind of fun to think about. Kind of makes you think of the planet Tatooine in Star Wars. So, once again, if you've just joined us, we have this really nice video of Saturn from our telescope. We took this video back in late September on a beautifully clear night. We wanted to show you a view of Saturn uh, tonight from our telescope, but the weather had other ideas. Here in Colombia, at least, it's cloudy and kind of windy and cold, and it's definitely a night when we can't really do much with a telescope because it's cloudy out. And it's a great night for some indoor, cozy, cloudy night astronomy. So I thank you all for joining me for some cloudy night astronomy from your homes. We're certainly having lots of fun here at the museum doing cloudy night astronomy from the comfort of our observatory classroom. That's actually our Clark telescope behind me. Okay, and Tracy asks, is Pluto not a planet anymore? That's right, Pluto is considered a dwarf planet. One of the big reasons for this is there actually are a bunch, many, in fact, other objects out in that part of the solar system beyond Neptune that are very similar to Pluto. They're basically these icy, rocky things. Um, and some of them are not very different in size from Pluto. Um, so they're like Pluto brothers and sister kinds of things. So do we call them planets too? And now do we have like many more planets in our solar system all of a sudden? Um, so that's actually one of the big reasons why Pluto was reclassified as a dwarf planet. There are several other dwarf planets in the solar system. One of them is actually the largest asteroid, called Ceres, and that's actually the closest dwarf planet to us. The big thing to remember with Pluto not being a planet is it really doesn't change anything about Pluto. It's still out there, of course. It's still the same object we all know and love. Because who doesn't really love Pluto? It's a really cool, awesome, cold, far away object. It's just what we call it. It's scientists have to call to kind of make definitions and classifications of what we call things. So basically, Pluto got reclassified from a planet to a dwarf planet. That again, it doesn't change anything about Pluto. It's just the terminology we use. Yeah, and Pluto does have a big heart on it. That's right. So the New Horizons spacecraft flew by Pluto in 2015 and took some awesome up close pictures. And yep, Pluto sure does have kind of a heart shaped surface area on it. So one of the things that's kind of fun to talk about whenever we're talking about the outer planets is their moons. So Saturn's got some really awesome moons. There's a moon called Titan. Titan has an atmosphere that's kind of like maybe the early Earth's atmosphere, and it rains liquid methane on Titan. There's another moon called Enceladus, and Enceladus has geysers on it. So there actually are astronomers that basically they spend their entire careers studying the moons of planets in our solar system. We have our planets, and then we have all of these really interesting moons, and the moons are in some cases worlds in and of themselves with their own really unique features. Do you think we'll ever find another Earth type planet? We actually have found planets similar in size and mass to the Earth. What we don't know is what are these planets really like? We have some ideas based on what we've observed, but no, do we know if they could have life in them or not? We don't know yet. One of the things that astronomers are actually uh, wanting to do is build larger and larger telescopes. We're about to launch the James Webb Space Telescope. Hopefully that goes well. And certainly larger telescopes are either under construction or planned for here on the Earth. Um, and one of the goals for these telescopes is to learn more about these Earth-like planets. Um, and maybe even see if there's something in in the spectrum of their atmosphere that could hint at life. In fact, this week, so every 10 years, the astronomy community does what's called a decadal survey. And so this week, the decadal survey for the 2020s was released. So it's the National Academy of Scientists in collaboration with a bunch of astronomers all over the country, and it identifies priorities for astronomy for the coming decade. So these are priorities for the 2020s. One of the big priorities for astronomy in the 2020s is identified by this survey is to start really addressing that question of what are these planets like around other stars? Could they have life? And this is going to involve building some big telescopes, like the James Webb Space Telescope, which is going to launch, of course, soon, and then big telescopes here on Earth as well. So, yeah, it might be that in the next 10, 15 years, we might really know a lot more about Earth like planets around other stars and what they're like, which is kind of awesome to think about. And if you just joined us, we are going to be up for about another 10 minutes or so. And we're showing a video of Saturn that we took on a day when the weather was actually quite a bit nicer. Today it's really cloudy and kind of cold, and a great night to do cloudy night astronomy. Of course, not such a great night for looking through a telescope. So we can't show you Saturn live, but we can show you this really beautiful video of Saturn that we took back earlier this fall. And we've been having all kinds of interesting discussions in the chat about uh, double stars and Pluto and finding other Earth-type planets and such. So if you do have questions or comments, feel free to pop those in the chat, and I will see those come in right in front of me, and very happy to answer. What size telescope did you use to take those images of Saturn? We actually were using a relatively small telescope. So we have our big 12-inch telescope that you can see kind of like right behind me and above my head. That telescope has a small telescope. It actually has two small telescopes mounted on it. One is a telescope that we use for looking at the sun safely, so it's got lots of filters. The other is a telescope that we use for imaging, and it's a 4-inch refractor, so quite a bit smaller than the big 12-inch refractor. So it's that 4-inch telescope that we used to take this picture. So you're asking, well, why did you use the little telescope and not the big telescope? Well, the camera we're using to take this video actually does not come to a focus on our 12-inch telescope. And I think that has to do with the fact that that camera has a very, very small sized detector. So the chip on that camera that picks up light's tiny, and it actually does not work very well on our larger telescope. So we actually have another camera we can put on the large telescope to see Saturn, but in its live view, at least, that camera makes a really small image of Saturn. So image size is really affected by your telescope, what camera you're using, or if you're looking through the telescope visually, what eyepiece you're using, its magnification. So there's a lot that goes into how big an object looks. Yep, this is definitely one of our smaller telescopes here. Anita asked, who names the asteroids? So pretty much anything in space or in the night sky is named by the International Astronomical Union. And there are various sort of things that go into making the decision. Different types of objects are named in different ways after different things. So it's actually, there's really quite a complex process of naming these objects. By the way, it was the International Astronomical Union that demoted Pluto from being a planet back in 2006. So it was those folks too who reclassified Pluto as a dwarf planet. So yeah, the whole idea of naming things in space is actually quite an operation. So we are getting to the end of our time, so we'll end at 9:30. So we do these live streams on the first and third Saturdays of the month. So our next live stream from the observatory will be on Saturday, November 20th. Hopefully we have better weather then than we did tonight. But one thing to know is because of the time change, we're actually going to change the time of our live streams. So right now they've been 8:30 to 9:30 for the fall. We're going to shift them to back or shift them earlier in the evening to 7:30 to 8:30. And hopefully that makes it a little easier, especially if you've got families or kids who want to see this. Um, that 7:30 to 8:30 time is just because it gets dark a whole lot earlier as we get off daylight saving time. So hopefully we'll see you again in just a few weeks. And hopefully we have better weather. So if you do have any last minute questions, feel free to pop those in the chat before we call it a night. Oh, thank you, Anita. Thank you. You're very kind to be such a faithful regular and participant for all our online astronomy programs. Good night, Anita. Thanks for joining us as always. All right. Well, we're going to go ahead and call it a night. So once again, our next live stream from the observatory is November 20th. That's a Saturday at 7:30 instead of 8:30. So we're moving the time earlier because of the time change. So hope to see you then. Hopefully we'll have actually clear skies that time, unlike tonight. And thank you so much for joining us and for all the wonderful interaction in the chat. It's been great answering your questions and seeing your comments. So have a wonderful evening, and we'll see you later.